Excellent. Well, just want to thank everybody for coming to our February 7th coffee talk. And last week we covered some stuff on the fertilizer front. We're just doing a little roundtable about how things were covered off on the farm and whatnot. And that was more for crop production. And we're fortunate enough to have James Tansey, who's the provincial specialist for insect and pest management for the province, on. And James and I go back a few years. In my previous life, I would have him do presentations to my group of people. And in the last short period of time, he's ran we'll call it a fresh iteration for this coming year of, I'm assuming, what the year in review was, looking in the rearview mirror, but also to forecast ahead and some of the things that are going on. And with that, I'd like to just welcome you, James, and let me know what you need from me for anything and all that stuff. But I'll just turn the call over to you.
Thanks, Dean. Yeah, no, I think I'm good to go. I can just get rolling on the presentation.
Awesome.
Okay. Anyway, thanks for the invitation, and we'll maybe get rolling on this. So, helps if I hit the right button. So yeah, general summary of the past year. I mean, so in real broad terms, we were looking at a very cool and wet spring. I'm sure all of you remember, and a relatively warm and dry late season. So that both of these have tremendous impacts on insect populations. Insects are ectotherms, so that is everything about them behaviorally, physiologically, enzymatically. Everything about them is influenced by temperature. And if things are too cool, that can have a really negative impact on some populations, on some. If things are too dry, that can have an impact on some. If things are not dry enough, they all have different climate factors that have an impact on them. So what is bad for one or good for one may not necessarily be bad for one or good for another. And we'll talk about some of those specific cases. So in short, we were looking at very cool wet conditions, and you can see here the cumulative rainfall, as indicated by the mud, interestingly enough, brown, but yeah, you can see broad swath of cool wet conditions. Now, these cool wet conditions had a really significant impact on some insect populations. We'll talk about some of those in particular. We were really anxious about what the grasshopper population was going to do in the spring. We were looking at the Environment Canada seasonal forecasts, and the seasonal forecast was for a warm, dry spring. And obviously that didn't happen. In their defense, it is a complex model. We live in a complex system in a continental climate. In the middle of a continent, there's a lot of factors that can influence what's going on here. But in short, the forecast was not very good, and so we were really fearing a lot of grasshoppers this coming year. We did have some localized pressures, but for the most part, grasshoppers were not the story that they were in 2023. So we had some slant-faced grasshoppers emerge in March, and sometimes in big numbers. This is it's a different subfamily than the two subfamilies represented here. They are typically rangeland species, typically feed on grasses and sedges, not normally considered pests of field crops. They can be a problem in rangeland and can be very numerous. I mean, upwards of 70 to 80 per square meter. And they were coming up in large numbers in March. So, I was getting some guys calling me, being quite concerned about the grasshoppers coming up in March. Pretty normal for them. These other ones here require 100-degree days base 10. So that is 100-degree days base 10 degrees Celsius. And we weren't getting there until mid-July and sometimes late July in some areas. And so a greatly delayed hatch on these. And when they did come up, the conditions were very wet. So they were subject to fungal outbreaks. So a lot of these nymphs were getting killed off by a fungus called Entomophthora grillii. However, we did see damaging populations, particularly of nymphs in the southwest and around the eyebrow and central Butte area, and some very large very dense egg beds. And I believe I have a photo coming up that Carolyn from SEIC forwarded to me. We also had some reports of damage in crops in August and some sprays going down for those. But again, not nearly what we saw in 2023. Pardon me, we're looking at 4 primary pest species, and well, maybe start at the bottom, because two-striped is the most numerous. After the conference that I attended yesterday, was good to see the lay of the land across North America. Where, talking to some U.S. Colleagues, two-striped is not the problem in the rest of North America that it is here. They're dealing primarily with migratory grasshopper, and we do have significant migratory grasshopper populations, but our big issue is two-striped grasshopper. We also have some small pockets of Packards and some small pockets of clearwing. Where this is important is because of the food preferences. In the case of two-stripe, this one is called folivorous. It really likes eating broadleaf crops, so canola, soybean, legumes, and it'll happily munch those. Packards is called ambivorous, so if it ain't nailed down, it's going to give it a go. Same thing with migratory, and this is why migratory has historically been a very important pest. And finally, clearwing, which is really a cereal specialist. So you can see large numbers of clearwing in a broadleaf crop, and I have seen large numbers in lentils where they're just not feeding. They're actually sunning themselves. So they're ectotherms. They're trying to get their internal temperature up. So helps to know what you're looking at, and that can influence control decisions. So this is that egg, one of the egg beds that I was talking about. So this was from the eyebrow region, and lots of eggs. I was seeing, similar things in the moose jaw area, and in a couple of their regions as well. So we depend entirely on SCIC to conduct our survey, and their adjusters and summer students get out to about 1,100 to 1,200 sites a year. So it is a pretty intensive survey. They're going to start late July to September. It all depends on what the grasshoppers are doing. And of course, the grasshoppers were a little bit delayed in their development this year. They were late in their hatch, but those warm temperatures meant they sped through their development. So most of this was in August and September. We did see heavy populations on a number of sites. So that is, right around that arbitrary, somewhat nominal economic level of 10 per square meter. I don't want to say it's arbitrary. Nominal is a better choice of words. So it is, it's an expert guess rather than just a number that's pulled out of the air. We did see significant populations, however, much more limited than we saw in 23. Once again, bivitatis, that's the two-stripe, and sanguinipes is the migratory. So those were our two heavyweights. Looking at the grasshopper population this year, not nearly as much red as we saw last. So we do still have some hot spots, and I think this comes with a bit of a cautionary asterisk, is although numbers are down relative to 2023, if conditions are suitable in the spring, that is, if things are warm and dry, and the seasonal forecast is looking pretty mixed right now, or not terribly conclusive. So if things do end up warm and dry, then we could see an upregulation of grasshopper populations again. So I think it behooves guys to keep a careful watch on the ditches in the spring, and we'll put out a notice through our social media and through our ministry websites and regional specialists if we're seeing lots of grasshoppers. Look first in the southwest. That seems to be where they come up first. So. Other cereal pests that can be important include wheat midge, and we had really good conditions for wheat midge, but we didn't have a lot of accounts of spraying. So very few accounts of spraying. I have no here. I've updated that since. It should be few. I got some reports of spray in the Balcarres area. Yeah, it's never none. But of course, we're very limited in the products that are available for wheat midge right now. And that includes dimethoate, full stop. We can't use chlorpyrifos on this animal anymore. It is no longer registered, so if you got it in the shed, you can't use it. So we did have very good conditions for these animals in May. They rely very heavily on moisture in particular, and especially heavy rainfalls to stimulate them to finish their development. If it stays dry, they can stay in a state called delayed diapause, and they can just hunker down in the soil under really dry conditions for years. Grasshoppers can do the same thing. So I have had some questions about that recently too, and yeah, they are stimulated by the environment to either hunker down, and they can tough out very challenging conditions for a very long time. So we do conduct a provincial survey, a soil core survey, and Tyler Wist with Ag Canada is also doing pheromone surveying, and I'll show you some of the results of that. pretty good overlap, and we're going to be combining those data to try to draw some conclusions. So we had very good conditions, we had very good emergence, and I'll show that to you on the next slide. So we had some pretty significant hotspots. You can see there's really good overlap with where we got that rainfall in May, both with the pheromone trapping and with the soil cores. So the soil cores are the bottom left, pheromone trapping is the top. So 38,000 male midges caught by, I'm not certain of the date here. Yeah, I don't have my glasses, apologize. That'd be mid-season though. A caveat with that is the synthetic sex pheromones only catch males. So this is when you're a teeny tiny girl and you got the urge to say come hither. You put out the come hither signal through pheromones. And the males are very sensitive to these, and they can detect individual molecules, 2 to 3 molecules, with their antennae. The individual molecules, those pheromones will bump into those antennae. The animals will point upwind and fly upwind to try to find the female. These little flies are very sensitive to it, but we're only catching males with this. So the assumption is we got a 1-to-1 ratio of males to females. That isn't the case in all insect populations. And males come up a little bit earlier than the females. They try to stake out a little bit of territory to wait for those females to come up. So it is, however, a good indication of local populations, in my opinion. And not just my opinion, I think that's probably the consensus view. This is one that we're keeping an eye out for. We've seen an upregulation of these populations in the last couple of years, which we haven't seen in about 15 years. So the last report in the Western Forum reports, again about 15 years ago for Hessian fly, and we are seeing reports of this. It's another cessid, so it's the same family as wheat midge. Another teeny tiny little short-lived midge. Larvae are the ones, of course, that cause the damage. These are typically a problem in winter wheat, but they can overwinter in brome, and they will attack spring wheat as well. And we have been seeing problems with lodging in spring wheat. So a good way to tell the difference between Hessian fly damage and wheat midge and wheat stem sawfly damage, pardon me, if it breaks off at the first node and you see it plugged, that's probably, or it's almost definitely wheat stem sawfly. If it's breaking off at the second or third node, you could be looking at Hessian fly, although there are a number of different things that can cause lodging. But if you see that weakening at those nodes, that's probably associated with Hessian fly feeding. You see these, it should be puparia, I apologize for that. What's called the flaxseed stage, that's functionally the resting stage. That's how they're going to spend the winter. And if you see those tucked into the crotch of the between the leaf and the stem, that is a Hessian fly. So if you do find those, please forward samples to myself or to Tyler Wist, whoever's closer, and we're going to try to rear parasitoids out of them. And so this is what we got. This is one that I reared out of the samples that we received. So of all the samples that we received at the Crop Protection Lab and Ag Canada in Saskatoon, we got 1 parasitoid. And this is a tiny little eulophid. You see the size of that puparium and how small that is. This is about 1/10 the size of that puparium. So this is a very, very small wasp. Most wasps are very, very small. So when I say most, I mean more than 90% of wasp species are very, very small. The stinging wasps, kind of think of those as the Godzillas of the wasp world. Freakishly large. Everybody makes fun of them. I'm big boned. I can't help it. So anyway, I'm sorry, I digress. Anyway, so we did have lodging, in a number of different regions. We're continuing to keep an eye out for this one, and we will be monitoring this one with a newly released pheromone lure in July. That's when populations peak. Although they will be moving from into fields and from stubble. So if you're going wheat on wheat, maybe reconsider. If you got lodging issues and you're going wheat on wheat, maybe reconsider. I realize a lot of guys have made their decisions at this point, but you may want to reconsider that. So sorry, I'm getting a little behind myself in time. So I hope I might go a little bit over. I apologize.
It's just the time you need. It's good.
Okay. The other animal I was talking about before is wheat stem sawfly. this past year was the second year of our we'll say rigorous sampling. We've been relying up to that point on anecdotal data that is agronomists and growers calling us and telling us about reports, but we now have a formal survey process. And sincere thanks to Sask Wheat and to SEIC for funding this survey. They also fund the wheat midge survey, and without their help, we couldn't conduct these surveys. So yeah, real hats off to those guys. So second year of our annual survey, and we're still seeing heavy cutting, and it's extending further north and further east than we anticipated. So we're going to be continuing with that, and I'll show you the map for that right away. So we had average cutting about 11%, with one field near Pence at 75% cut. So really heavy population in that site. So here, let me just back up. It's not the adults that cause the damage, and there are no products registered for the control of these animals. There is, we'll say, some evidence that seed treatments with neonicotinoids because they are systemic, can have an impact on them, but the data isn't really hard on that. So there is some evidence for that. None of those treatments, however, are specifically registered for their control, and there are no foliar controls registered. And the reason being is, by the time you're seeing females, the jig is up. I mean, they've got the majority of their eggs into stems. So the larvae are the ones that are causing the damage, and they're going to be feeding within the stem. So this is why solid stem varieties are beneficial. This restricts their movement, doesn't kill them outright, but the plants are more tolerant to their feeding. So these are what the, by the numbers, this is what the map looks like. So we do have some hot spots. And once again, a little further north and a little further east than we anticipated. And so our contractor, we were lucky enough to get Scott Mears, the former Alberta entomologist, who actually did his master's on wheat stem sawfly. And has a real passion for this animal. But yeah, he's now retired and still taking the odd contract, and we were lucky enough to get him to help out with this. So he'll be doing about 100 sites. I'll be taking on another 20 sites in the Regina area. So we're gonna press a little further north and a little further east, and see what's happening with that population. So stay tuned. Yeah, we do have some serious numbers of wheat stem sawfly in some areas. Wasn't much of a flea beetle year, which is kind of a pleasant surprise. We did have some damaging populations in some regions. I mean, they're never not a factor, particularly in the northeast, in the Spiritwood area, and in the Tisdale region. We had some damaging populations of striped flea beetle, and we had some, a few populations in the Kindersley area and a couple other areas of the crucifer flea beetle. Crucifer flea beetle likes things hot and dry. Striped flea beetle likes things cool and wet. There's also differences in their susceptibilities to insecticides, whereas the striped flea beetle is less sensitive to the neonics in particular, but also to some other insecticides. So if you're treating with a neonic insecticide, it will be less hard on the striped flea beetle than it will be on the crucifer. So crucifer can be well controlled if conditions are good, and I'll talk about that in the next slide. But what we've been seeing over the past several years is a move of striped flea beetle from northern regions to southern regions. The current thinking is that is associated with these two factors. So we've got, we've been, coming out of a real dry spell, and that has a relatively moist spell, and that had driven the populations down. With the dry conditions, that's driving the populations back north. But there are still damaging populations of striped all the way as far as southern North Dakota right now, and they can be regionally important even in southern regions. However, most of the south is dominated by crucifer flea beetle. The reports on buteo start have been excellent for both. So it seems to really do the trick for both species. It is a premium product. You do pay more for it. I don't want to pretend this is a buteo start commercial, but it does seem to work well for both of them. So significant striped populations, once again, in the northwest and northeast. Some reports of multiple sprays. Again, not nearly what we've seen in previous years. We did have moderate pressure in the rest of the province, mostly associated with crucifer flea beetle. We also had some significant populations of crucifer flea beetle late season, The prediction based on fall populations and spring populations, really loose connection. They are excellent flyers. They can fly miles. They don't fly really high. So I did some trapping back when I was a grad student. The highest I was catching these things was about 18 feet. Most of the flight 1 meter or lower, so 3 feet or lower, but they can really get out and about, so fly miles. So once again, that connection between fall populations and spring populations, not super solid. So once again, cool, wet weather seemed to be the theme over most of the province. That had prolonged seedling development, and that influenced the ability of these seedlings to take up some of these seed treatments, systemic seed treatments, and could reduce the efficacy of some of these. So we had some issues with or some reported issues with cutworm, more in Alberta than we saw in Saskatchewan. And a lot of these were associated with just, those group 28 insecticides, that Fortenza and Lumivia, not getting drawn up into the plant and providing protection. Both John Gavlosky, the provincial entomologist from Manitoba, and I collected large numbers of crucifer flea beetle and shipped those to Dr. Boyd Morey at the University of Alberta. He has a postdoc right now who is working on insecticide resistance. She tested these for group 3 resistance, and happily we are not seeing group 3 resistance. So group 3 is going to be your Desis and Lambda and permethrin, cypermethrin. And although Desis seems to be a real go-to for flea beetle control, if you're not seeing the control you'd like to see with the seed treatments. So happily, despite years of application and heavily reliance on group 3, we have not seen the emergence of group 3 resistance in these populations, but we will continue to look for it. One thing that was a little bit troubling at our recent Western Forum on Pest Management meetings in Regina in November, Boyd presented results of insecticide testing for crucifer flea beetle with group 4 insecticides. So that is neonicotinoids. And he was finding that their sensitivity compared to the work that I did in 2007, 2008, looking at these populations, is lower. So there's some concern that we may be looking at increased tolerance in crucifer flea beetle to the group 4 insecticides. Once again, it's a little soon to say resistance is developing, but we are seeing decreased sensitivity in stripe populations to the neonics as well in North Dakota. Stay tuned, that publication should be coming out soon. So maybe cause for concern, it's a little soon for alarm. So we will continue to monitor this. If we do see confirmed resistance, then of course we'll make an announcement about that. Diamondback moth can be a very problematic animal, and when it does outbreak, it can be devastating. Happily, we haven't seen a major outbreak in recent years. The current thinking is that they are migratory populations, so they're overwintering in Florida. Most of ours are coming from Texas, but they can come from Florida, North Mexico, or from western regions. So if you look at the flyways that the migratory birds take, those same winds are pushing these animals up from southern reaches. So this is a picture from Georgia, I believe, and this is kale that has been heavily munched by diamondback moth larvae. When these winter crops are harvested, typically in our spring, they have a 12-month field season in that part of the world. Of course, they have winter crops and summer crops. When the winter crops, and a lot of brassica veg is grown there, when those are harvested, then the jig is up for these animals. They take flight and they get into high altitude winds, and these are the same winds again that are helping to move the migratory birds up. They're flying at about 300 to 500 meters, and the air is a little bit warmer in that region. They can get as high as 4 kilometers, so they can fly very high, and they can be moved by these winds great distances. So that is 1,000 kilometers a day. So really what's happening, they're taking flight in Texas, getting up as high as 4 kilometers and being pushed 1,000 kilometers a day. They encounter conditions that are really not well understood, and at this point, at least by me, and falling out of the air column. So they're falling out en masse, onto the Canadian prairies, and we really have this connection from point A in Texas to point B on the Canadian prairies. So we track, or Ag Canada tracks, and we keep an eye on this, the wind trajectories, and that'll help us get a little bit of predictive power. And we have sentinel sites to keep an eye out for it. What we were worried about this year is we saw really early occurrence of these animals, and they looked in excellent shape. I mean, they looked brand spanking new, shiny and new. So they looked very much like they had not flown thousands of kilometers. They tend to get a little bit tatty when they're bouncing around in the winds at those altitudes. These looked in very good shape, and we were getting reports of that. So John was seeing that in Manitoba. We saw it here. Shelley Barkley was seeing that in Alberta, and so we got to be a little bit concerned that we were looking at overwintering populations. These can be serious problems in seedling canola if they arrive early or if they overwinter here. Before I get to the conclusion of this, because obviously we were a little bit concerned about this, because that would change our control strategy, that would change our extension messaging, obviously. So we submitted adults that we were catching as part of our sentry sites, and as it happened, Tyler Wist had a collaboration with the University of Western Ontario to do deuterium ratio analysis. So what this means is that there are two stable isotopes of hydrogen. One is called deuterium, and it has a proton and a neutron. One is called protium, and it only has a proton. And both of these exist in stable ratios in different parts of the world. So the ratio is going to be different on the prairies than you're going to see in the American Midwest, than you're going to see in the American Southeast. And these are relatively broad swaths, but the ratios are stable. So if you do, that hydrogen, or those hydrogens, are going to get incorporated into water. Water's going to get incorporated into plants. Insects are going to feed on plants, and that hydrogen is going to get incorporated into them. So if you do that ratio analysis on these animals, you can get a pretty good idea of where they came from. And so that work was done, and happily, and here's the end of the story, our diamondback moth are not overwintering here, not in any kind of numbers, which is a huge relief. So they are still moving up from the south, so they can still be a problematic pest, but our sentry system will continue to work well, which is a relief, not having to change our monitoring system. But another interesting conclusion came from this as well, is it looks like they are actually engaged in point-to-point migration as well as a stepwise migration. So there's a portion of the population that is flying and dropping out of the air column in the Midwest, completing generations there, and then continuing their flight. So a little bit like a monarch butterfly. So we will continue to keep an eye out for this. Our sentry sites look like this. So if you happen to be driving down a remote road and you see one of those, please don't knock it over. If you're driving a sprayer, please don't knock it over. That happens a lot. So these are synthetic sex pheromone traps. Once again, we're catching males. Yeah, we're taking what a male thinks is going to be a very good day and turning into a very bad day, and then we count them up and we get an idea what the local population is looking at. So happily, this past year, we had very few reports of spraying, and the population was low to moderate. So we will continue to keep an eye out for this. They did see significant populations in the Peace Country in Alberta, so a fair ways from here, and in southern Manitoba. So again, we will continue to keep an eye out for these ones. Bertha armyworm is a native species. This is one that we do monitor for as well. We had 292 sites monitored, again, with synthetic sex pheromones, monitoring for the adults. Of course, it was cool and wet, so emergence of these animals was greatly delayed, and 3 weeks delayed in some regions. So we were seeing peak emergence as late as early August. And our typical messaging is start monitoring for a larvae 2 weeks after peak emergence. And of course, we're getting pretty close to harvest at that point. So I mean, very few reports of damage associated with these, and no reports of spraying. We did have some mis-IDs, so we did have some clover cutworm that was causing problems in the Northeast that ended up getting sprayed. If you do have clover cutworm, a really good way to tell them apart, because superficially they look very similar. If the stripe is pink, it's clover cutworm. If the stripe is yellow, it's Bertha armyworm. You can see Bertha's got a lot of different color morphs as well. So you can see greens to browns to blacks to grays, but that yellow stripe is quite distinctive. And again, if you got a pink stripe, any control product that you would apply for Bertha armyworm is going to work for clover cutworm as well, and really consider the thresholds to be about the same. So we did have moderate populations, but again, no accounts of spraying, and really nothing to write home about as far as adult catches went. We are going to continue to monitor for these ones. They can be an outbreak species, and when they do outbreak, they can cause a lot of damage, and they typically run on a cycle of about 6 to 8 years. Not all pests are cyclical, but this is one that typically is. And they are driven in large part by the activity of their natural enemies, in particular viruses. So in their case, we're overdue. So typically every 6 to 8 years, we're overdue for an outbreak. We're going to keep looking out for these animals, and if we're seeing problems, then of course we'll put the word out through social media and the ministry website. So keep an eye out. Also keep put Prairie Pest Monitoring Network in your list of favorites, and keep an eye on that. There will be prairie-wide. We share our data with Prairie Pest Monitoring Network, and you can keep an eye on what's happening prairie-wide. Cabbage seed pod weevil. These are an invasive species, so this is another one that we monitor for. They are continuing to work their way north and east, although we have seen a retreat in their populations in recent years, owing in large part, I think, to the dry conditions. Both adults and larvae can damage. You can see that this animal has got the long nose on it is actually a rostrum, and it has the traditional insect feeding parts, mouth parts on the end of that rostrum, but they're greatly reduced. So what she is going to do is arrive at buds and arrive at early flowers and munch away on those, and her feeding can result, and his feeding can result in bud blasts, especially under warm conditions, and that can have a yield hit. But most of the damage is associated with larval feeding. So she is going to chew a hole in that developing pod, and that's really where you should be controlling these animals, is at late flower to early pod. And she's going to chew a hole in that developing pod, lay a single egg in it, turn around, drag her butt across it, and deposit what's called an oviposition deterring pheromone. And what she's doing is putting up a big neon sign, in smell-o-vision, I suppose, to other females to say, don't put your egg in here, it's occupied. You look at a pod, that's a very finite resource, and you got one larva growing up in there, you get a new larva, especially if it's smaller, it's going to get eaten. So it behooves that other female to not encroach on that resource, because they are happily cannibalistic. So we did have some heavy populations in the southwest, and many of these were economic, and some sprays were going down in the Swift Current region. And looking at the map here, yeah, we had some heavy populations. So populations like we haven't seen in a little while. We have seen an overall retreat from northern regions over recent years, but they are now established in Manitoba, although the numbers are low currently in Manitoba. But John Gavlosky continues to monitor for those. As far as Saskatchewan goes, we will continue to monitor for these, although we're having a bit of a shortfall as far as resources, personnel resources for surveying this year. We've got some potential solutions, and we're going to be fleshing those out. So we'll get the people in place. We'll get the bodies out, and we'll get the bugs counted. So it's just we have to be a little more creative about it this year. Pulse pests, including the pea leaf weevil, are monitored, or primarily the pea leaf weevil are monitored. These are both, again, invasive and damaging as adults and larvae. You can see the characteristic notch feeding on a pea seedling there, around the edges, pretty distinct from what you might see from a small cutworm or a grasshopper nymph. Grasshoppers tend to be messier feeders. These ones are we'll say tidy feeders. They really form those really conspicuous C-shaped notches, really quite characteristic of this group, which are called short-snouted weevils. And you'll see the different ones with different host preferences. The feeding looks very similar. These ones are feed entirely on Fabaceae or entirely on legumes. Only 2 true hosts for these. Adults will feed on a broadest array of different legumes, including alfalfa and clover, but they can only complete development on faba and field pea. So they do that by tunneling, and there's a picture of a larva on the top right there. The larvae will actually tunnel into that rhizobium nodule and clean out the contents. And so there can be a significant hit associated with these, up to a 30% yield hit. So what we were seeing last year was this, and we were becoming a little bit concerned for northern regions with a real upregulation in populations. So one thing that was characteristic about the winter of 2022-23 was a lot of snow cover. And I did some modeling a few years ago, and there's a real good connection between snow cover and survival of the adults over winter and damage. So once again, they're European, they're not very cold hardy, and they really rely on that snow cover to survive over the winter. So they have what's called a supercooling temperature. All insects do, I don't want to say all, but temperate insects do, where they can depress the freezing point of their blood, by introducing proteins or introducing alcohols or sugars to depress the freezing point of their blood. It's not the temperature that kills; it's the formation of crystals that ruptures tissues. So in the case of these guys, they can suppress their supercooling temperature to about -7, -8. I know that's kind of a that's like a cool day in June in this part of the world, right? So if there's no snow cover under the snow, of course that can be 0 degrees between the underneath the snow and into the soil. So they're well protected if there's a good snow cover. Of course, the snow cover in 2023-24 was relatively poorer or much poorer, and we saw a real collapse of those populations. Collapse is a strong word. Well, a real retraction of these populations. So with the snow that we've had this year, though I haven't looked at a snow map in the last couple of weeks, but we've certainly seen some snow relative to what we've seen in previous years. So there could be a protective effect of these. Keep an eye out for pea leaf weevil. Again, foliar applications not recommended. The yield benefits of that are not well established. Seed treatments. If you're in a region, and really it's just that eastern region where you should have some concern, consider a seed dressing with the neonicotinoid. Thiamethoxam cruiser, I believe, is the product. So we did have, on the note of insecticide resistance, we had several reports of lambda-cyhalothrin products not doing the job on lentil for pea aphid, and we had a lot of reports of these coming in. So guys are going out with silencer, hitting it pretty hard, and coming back later, and the populations had not been reduced, and we're actually still increasing. So this spurred us on. So I reached out to Tyler Wist and Sean Prager and Mike Brown with SPG. They brought Tyler and Sean brought in their shared PhD student, Tyler Hartle, real sharp kid. If you get a chance to interact with him, he's very bright, and I think has a real good future. But anyway, brought him into the group. We put together a test kit. So this is based loosely on some work that I did in Florida, working on Asian citrus psyllid, and developing a field test kit, so a rapid test kit for insecticide resistance. And what we did is we loaded up these vials with full rate, half rate, quarter rate, and a water control, and put them on a hot dog roller until they dried out. So we dried the insecticide off, so the insides of these vials were coated with dried insecticide. We now have a lab with a hot dog roller. So that was my introduction to the lab in Florida, was walking in and seeing a hot dog roller and going, what the heck are you guys doing here? And yeah, now I understand, and now we have a hot dog roller. So anyway, we deployed these field kits, and thanks very much to the agronomists and the SARM technical advisors and our regional crops extension specialists for helping out with this. We had, you can see at the bottom there, we had 75% survival of one field site, and that's a bit alarming. So we have this test kit in our pocket. We're going to be looking at some other rates to put in there as well, so we can actually work out LC50s, and do a proper probit analysis on that. I won't get into the statistical weeds and nuts and bolts on this, but we will continue this. We're also going to be starting what's called a leaf dip assay at the crop protection lab, and if we're seeing what looks like emergence again, we will be examining it and throwing some resources at that again this year. So forage pests, we had true armyworm issues in the northeast. Issues is strong. There were catches. This is a side of table survey that was really championed by Joanne with the forage seed growers, and really only one field sprayed, but there were moths caught. And we also had traps in the Saskatoon area, and in the Craven area, we didn't catch any in those areas. Happily, true armyworm is another migratory pest, moves up from the States, and powerful flyers, can move great distances, and was a significant issue in the Saskatoon area in Weed and Durham in 23. So we're quite keen to keep monitoring for this. We're uncertain as to whether we're going to keep monitoring for it, and this is a resource-based decision in 2025, but we're hoping to keep that going. And wild rice, we had there are First Nations organic wild rice producers in the north who were hit very hard by this animal. So we got our first reports of this were photographic evidence, and identifying these caterpillars through pictures can be really challenging. Happily, I managed to get it right and confirmed it through Tyler West doing DNA barcoding. So it's I feel better about getting things right than getting them wrong, obviously. So we got an ID on this, and it let us do a little bit of research or a review of some of the literature that's been produced on this animal. It is a very infrequent outbreaker. So, I mean, we had the first account was from 1957. The next outbreak was well into the 1960s in Manitoba. It's been decades since we've had an outbreak in Saskatchewan. Because of the conditions in that region, they really don't have any control options. There are no commercially produced sex pheromones to have with lures, and there are no products registered for organic producers in fish habitat. So their options are extremely limited. I'm hoping to get up there in a couple of weeks to see what the overwintering population is doing. There's been some talk about tilling up sloughs, and they don't overwinter underwater. So I'm imploring them not to do that. All they're going to do is damage those systems. They hit the water and they move to the water's edge and then move pretty far inland to overwinter. So there's just no point in chewing up those aquatic systems. There is a significant portion, however, that overwinter in stems, so there may be some benefit to burning. So we're going to go up there and take a look and cut some stems and see what's happening, and then hopefully we can provide these guys with some recommendations. We had significant populations of root maggot in the Outlook area in Brassica Veg. Happily, we have a new emergency use registration for a group 30 insecticide called Cymegra, which is a new mode of action. You don't see new modes of action coming down the pipe very often. This is the same mode of action as Taraxa that's commercialized for wireworms in wheat. Works like a hot darn. However, it is highly toxic to pollinators. And however, it is not systemic, and the timing of application means that pollinators should not be exposed to this insecticide, and the risk is considered low. So emergency use registration stands in place, and I think that is moving forward to a broader registration, or the push is on for that. This is the final insect I'll talk about. This is spotted wing Drosophila, another invasive. If it ends in berry, this thing is attacking it. So it doesn't care if you're a commercial grower or a garden grower. Also includes tomatoes. This is an animal that was, the climate models indicated, was not to establish in Saskatchewan in significant numbers. However, it is well established. It is broadly distributed and well established in Saskatchewan now. Forest Sharp, our fruit specialist, is continuing to monitor for these. And again, the cool wet weather really delayed their emergence, but we saw a real upregulation of their populations as the weather warmed up. So once again, we will continue to monitor for these. You can see the maggot growing up inside this raspberry here. Of course, for commercial growers, that fruit is unmarketable. Finally, the gopher bug. We had several accounts of Richardson's ground squirrel populations being very damaging, and this is a photo I took from the southwest. I think about an hour south of Swift. Two things to note: A is you can see the cereal crop to the right and the seedling canola crop to the right, to the left. One of these things is not like the other, so they really like canola. And you can see how far into the field they got this year. I've never seen anything like it. I've never seen them get that far into a field and to do that broad of damage. And this is after second planting. So he put one planting down, the gophers came in, cleaned them out. He put another, he put gopher control products down. He actually spent over $30,000 on gopher control products. A pretty big farmer in that part of the world, but yeah, the applications went down late, in my opinion. If you got green feed up, they're going to feed on that. They're not going to feed on the baits. So you need to get the baits down real early, but very damaging populations in some part of the world. This comes with a big asterisk because the overall SEIC data indicated that gopher claims were actually lower than they have been in a couple of years, and the indemnities paid for gopher damage were actually lower than they've been in a couple of years, and significantly lower. So the actual gopher damage was spectacular where it occurred, but highly localized when it was serious, though they could be very damaging where they occurred. We did some work in collaboration with Alberta Agriculture on sites in Alberta and Saskatchewan. This is, we were looking at the deregistration of strychnine, which of course is now deregistered, and we wanted to do an assessment of some of the alternatives that are registered for strychnine in a replicated field trial. So we had a multi-site, multi-year replicated field trial to look at the efficacy and non-target effects of some of strychnine versus some of its registered alternatives, and we got a couple of zinc phosphide baits that looked really good. One of the anticoagulants looked pretty good, and this is again from one province from one year. The rest of the results were pretty similar to this. So Rosol, that again, everything comes with asterisks. Rosol takes a lot longer to kill. So we ran this study for a week. Rosol can take a week to kill and can be a multi-application bait. We put 2 applications down for Rosol, 2 applications down for Ramic, single applications for strychnine, Rosol, strychnine, burrow oat bait, and ZP rodent oat bait, and got better efficacy with the zinc phosphide, comparable to what we were seeing for strychnine. Cost per acre is actually lower for zinc phosphide than it is for strychnine. More expensive for the anticoagulants, and so we're looking about $13 per acre at the high rate for strychnine, about $8 an acre for the zinc phosphide products, and close to $40 an acre for the anticoagulants when you take the multiple applications into consideration, plus reduced efficacy, plus there are issues with residues. With the anticoagulants, they take a while to kill. So something that takes 7 to 10 days to kill, that's the toxin is moving from the gut of the animal into into the muscle tissues, and that animal's getting weaker and weaker and weaker as it dies. So I mean that's a really good opportunity for a scavenger or a predator to get poisoned. So your potential non-target effects and the benefits you might see from those predators on gopher populations, you may be losing. Some guys still swear by Rosol. I mean, good on them. It is still it is still a registered control product. We have demonstrated that it does have efficacy. Just take these other things into consideration. Also consider too that when things green up, the green plants produce vitamin K. Anticoagulants mess with vitamin K. Vitamin K is the building block of what causes coagulation in our blood. So if you mess with that, you reduce coagulation, and you promote free bleeding, much like warfarin. Vitamin K ingested through the consumption of green plants, that's the antidote. You've now replaced that vitamin K. The coagulating can continue. No antidote for strychnine, no antidote for zinc phosphide. So once poisoned, an animal is doomed. And in the case of zinc phosphide, it can kill relatively quickly in about 15 minutes. Another benefit of zinc phosphide is that in the acidic environment of the animal's gut, it breaks down to form phosphine gas, and that's the thing that really does the killing. Kills quickly, but the gas escapes the cadaver, so it's going to leave very little in the way of residues in that animal. So it is a relatively, from an environmental perspective, safer alternative than the anticoagulants. Plus, as we've demonstrated, quite efficacious. We also encourage tolerance to predators. These are a couple of pictures from my place. We had a gopher or a badger and two cubs move in. They were actually quite hilarious. My wife would no longer go for walks with the badgers out there, but they are badgers. They did a real number on our gopher population, and they can reduce a population by 60 to 80%. We also had short-tailed weasels that were stealing babies away as they were still nursing underground, which caused a lot of commotion. And we installed a raptor platform on the place. We have northern harriers, which are happy munchers of Richardson's ground squirrel. So it's an integrated approach. So chemical plus biological plus cultural. And you exert all of these pressures on Richardson's ground squirrel populations, you're not going to eradicate them. They are native and ubiquitous. Any hopes of eradicating these animals is wishful thinking, I think. But you can limit their populations to the point where you can limit the damage. There is also a gopher control program through SARM where you can apply for a rebate on chemical controls of 50%, and there is no cap on that. So if you're spending a lot of money on gopher control, you can apply for a 50% rebate on those. And there's also a 50% rebate on non-chemical controls like raptor platforms. That, however, there's a capped amount on that one, but we built that one for less than $200. And finally, I'll take any questions. I apologize, I went a little bit over, so I got a little more detailed than I anticipated.
It's all good. So just an open floor. Thank you, James. That was very informative. Does anybody have any questions right off the hop? I've got some myself.
Oh, fire away.
So you indicated that you have maybe a deficit in bug counters of staff or extension people. What's your fix for that?
Well, yeah. See, we've got a couple of terms that are ending, and of course, we can't rely on people who are not employed. And a couple of mat leaves. So yeah, losing 4 people on this. In addition, Ag Canada is a little shorthanded as well. So we are looking. Ag Canada will be bringing in a contractor. So we're looking for qualified people. And in that case, I think that one is a full-time position. We'll be hiring part-time, and we actually have some candidates for the ministry. Where we'll be bringing in graduate students who are writing and have a little bit of time where they can contribute to our monitoring as well. So I think again we'll have to be a little bit creative about it, but yeah, we'll get her done. Yeah, we'll get out and it it'll mean some quality time in a slightly old crappy truck for me, but that's kind
whatever.
of that's my happy that's my happy place actually. Yeah.
Well, it's an excellent opportunity for those that want to pursue or consider an extension opportunity, just to kind of get their feet wet, right? And get out there, get their boots on the ground, and see what they think of the smell of dirt and all of the good things that go with that juju, right? So that's cool.
Yeah, absolutely. No, if you do know students or people who are interested in careers in ag, I mean, there are opportunities with the ministry.
Yeah. Okay. One thing and it really depended on the catchment zone, but that wheat stem sawfly appeared to be a bit of a bear for folks. But a lot of it discovered post it happening to them, so to speak, and some maybe they knew it was there and all the rest of it, but for this year, I'm not sure what it's been like for them to dial in seed for this year for that. But last year they did consider it, and they said, geez, I couldn't quite find it and all that stuff. So
they were looking for solid and semi-solid, eh?
Yeah. And so I'm assuming that would just be through their local seedsman. For what can you do about it, right? And that would be one logical thing for them.
Yeah.
And that, but it was pretty devastating after the fact when they go and they see, geez, the crop's laying down, and why, and well, they found out why, right?
Yeah.
You kind of
Yeah,
thing.
no, it's,
So
I mean, I'm not, I don't really follow the varieties. And so I can't really comment on what's available for solid and semi-solid. I think the selection's pretty limited right now though. And I'm thinking
yeah,
availability would probably be pretty limited.
yeah. With the temperatures that we've had this year, you indicated that some of the European bugs are more likely to have a snow cover survival rate. Have we hit critical temp that will will eliminate that, or has it been adequate in your mind, or when would you know that we should have our heads up, because we've got some snow cover this year?
Yeah, yeah, no, I think the snow cover will trump very cold temperatures and will for a very long time. Yeah, snow is a really excellent insulator, and you can see significant huge differences in the temperature below even a foot of snow to ambient temperatures. I mean, it's a really excellent insulator.
Mm-hmm, mm-hmm. Yeah.
Yeah, so I mean
Okay.
the two I mean very cold conditions, and when they're exposed to it will kill grasshopper eggs too. But grasshoppers are relatively cold tolerant. I won't be able to. I have another slide that's not part of this one, but in the case of clearwing, those ones are particularly cold tolerant, and they can take exposure to temperatures in the -20s for weeks before
Mm.
suffering significant mortality. Some of the other ones are a little more sensitive to it, but they're still very cold hardy. I mean, they did evolve in this climate, and they got some tools in their kit to survive it. So even some other invasive ones, spotted wing Drosophila overwinters as an adult. Its supercooling temperature is about -25. So it is a tough little fly.
Yeah, and once you put that snow cover over top of it, there, it's not going to be that. So there
Oh
you
yeah, yeah.
go, right?
It could be
So
close to zero.
yeah, well, and I was really it was interesting to me to discover that some animals can do their own antifreeze with their blood. I had no idea that was a thing,
Yeah, so
frankly.
it's I mean, there are different methods for doing it. One will be some will actually produce what are called nucleation proteins, where they're actually they'll have a site of crystal formation and simply limit the size of crystal formation. Some will have
Mm,
alcohol, some will have sugars, where you're really just chemically depressing the freezing point of the water in their blood.
that's crazy. Huh.
Yeah, their
Okay.
bugs they've been around a while. So
Yeah, 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 yeah. Year in and year out. Yeah,
yeah,
they have the way of figuring it out.
yep.
Great. Well, thank you very much. I'm going to quit recording. Again, it's an open floor, so if you guys happen to have any question for James, I don't know, Ryan, if you've got anything relating to the alfalfa side of things and whatnot. Yeah, go, Ryan.